All right. So the plan is, depending on the Delta variant and how things go, that will continue for the indefinite future of meeting just like this, a hybrid model. Probably be meeting most of the time here. If anybody ever wants to offer up another location, your business, or if you know another place that'll let us meet for free, that's awesome. We can try that, but otherwise we'll be meeting up here.
Are you sharing?
I am not. Thanks, Dennis.
Good to share.
And so I said it earlier, but just for anybody that watches this later or that has joined recently, the next meeting, we will be talking about the AWS CDK version 2.0. So I think that'll be real interesting. I've said it before, but if you guys have any job openings or you're looking, let me know. I like to try to connect people when I can. So let me know if you got anything there. Otherwise, thanks everybody for coming. And Dennis, if you want to take over sharing,
sure,
give you the floor. Everybody online, feel free to speak up, ask questions. I'm sure Dennis would love any input and to make it interactive.
Absolutely. So can you guys, yes, you can see that. All right. Here we go. So as David mentioned, my name is Dennis Barger. Both David and I are from a company called SEI. I have a couple of slides here about SEI. We're not going to go through those.
Why not?
Yeah. So we are kind of we're an employee-owned consulting company. We're really small. We do a lot of management technology consulting. Might resonate with you guys a little bit more, some of the things that we do and why why David asked here, and we've had some other people. But keep in mind, this is not an SEI meeting, so I'm not here to sell SEI. Honestly, I'm not here to sell AWS either, because we're going to have a little bit of that conversation tonight. But we do a lot of stuff in data and analytics and concept and delivery and strategic operations with companies and technology enablement and a variety of other things. So if you'd like to learn more, I'm more than happy to talk to you about the company. I personally love the place. I've been with them for a few years, and I plan to be there until I retire, which should be soon, hopefully. So what I wanted to do tonight, and first off, I hope this can really be kind of a discussion. We're a small group here, probably a little bit smaller than what we thought, but it's the first time this group has been together in person for what, 2 years almost?
Yeah.
So that's a pretty amazing thing that you guys kind of came out for that. But you know, normally in this type of situation, somebody gets up here and they present some slides, they show some code, they might demonstrate some of that code. And I'm going to present some slides and I'm going to show some code. And I don't know if I'm going to demo anything, but we'll see what happens. But what I'd like for us to do beyond that is to make this a little bit more interactive. So we're going to talk about this concept called customer data platform. Years ago, it was a nebulous thing, and we'll kind of go into that a little bit more. I'm going to show you, so we're going to take a minute to kind of describe what it is. Look at a particular case study and then look at a design pattern in AWS for how. And after that, I'd like for you guys to tear it apart. Let's use this as kind of an opportunity to redesign what this thing should be. Figure out, because I've kind of put in here a couple of places where I think there are some architectural gaps. And let's kind of talk through that and see how we would make this better. So before we kind of dive into some of this stuff, and I don't know if I can see the hands of people online, but I'm just kind of curious. We were talking ahead of time what everybody does, but how many of you are actively building AWS solutions now, just to show of hands? Okay. And we know Michelle is. She's got her 10th degree now.
You can see them up there.
Okay.
On the right.
How many of you in building solutions have probably been building for the past 3 years and what you have been building have been more data-related solutions. I see some hands still showing. Great. So if you were here last month, you probably listened to John Longo go into a lot of infrastructure stuff. We're not really going to go into infrastructure tonight. We're going to be looking at this more from a solution perspective. But if you got questions about some of the networking and security and infrastructure things, let's bring them up, because frankly, if I don't know the answer, which could be possible, I bet there's somebody here that does. So it's a conversation. If you got questions, please let me know. So what is a customer data platform? I guess, has anybody ever heard of this thing called a customer data platform? All right. I didn't either until a few years ago. It's really something that's kind of come about. And if you had asked me a few years ago what it is, I would tell you it's an ETL platform. So I did a little bit of research. What Gartner calls it, it's a marketing technology that unifies a company's customer data. All right. Allows them to enable customer modeling and to optimize the time and the targeting of messages and offering. It helps personalize an experience to a customer. Forrester recently did a survey, and they framed it a little differently, and they added the words pre-packaged data lake, advanced data integration, unified customer profiles, and deep analytics. So they went from, it's this thing that connects to other things and allows me to personalize messages, to it's much broader. It's actually a platform that encompasses a data lake. Now the question, are you guys familiar with the, when I say data lake, does that resonate with you? Okay. Because it can get really confusing between historically, what is a data warehouse and what is a data lake? What is a data mart and what is a data store? And we can kind of have that conversation too. And then Wikipedia, who's a knowledge of all, basically said it's just a collection of software that persists unified customer data. So it is kind of this thing that is a hub, and we'll kind of talk about that in just a few minutes. But there are some vendors out there that are actually doing some great work in a customer data platform. I've actually had a client recently say, should I buy a product? Should I build a product? And when David and I kind of work with clients and they're asking us to build something, that's really one of the first questions that comes out of an executive. You know, is it more beneficial for me to spend the money up front to buy some technology that somebody's already built that is a managed service? And oh, by the way, we're starting to see a lot of managed services inside of AWS. Or should I have my engineering team build something where I can really define what I want to have out of this? This is a really common conversation. And when you get into the CDP market, that conversation gets really escalated quite a bit. 5 years ago, customer data platforms, that market was about $300 million. Today, that market is at $1 billion. $1 billion. And in that market, there's about 44 vendors out there who have niche platforms and niche services. And 5 of those represent over 90% of the entire market. So when people kind of think about, I want to implement a customer data platform technology, they generally look at 2 companies. One's called Signal, the other one's called Segment. Both of them are very fine pieces of software and do a great job. So then the question you may have is, and why are we sitting here talking about building this in AWS? It was to me by a client and executive, should I go out and buy Segment? Should I build it? And what led to a lot of that conversation is he was implementing a digital transformation across his entire organization, where he wanted to take his legacy Microsoft stack, which was a monolithic web stack, and had no concept of data platforms or analytics or any of that. And he goes, I want to transform all that. I want to move it into the cloud. We've made a strategic decision to go to AWS. Now my next question is, do I bolt in the Segment product because I really need to have this customer personalization? We spent time, we did analysis, we put together a strategy, and we came back and said, you really need to build this in AWS. You can always bolt it back on later, but you're putting a lot of investment in building solutions native to AWS. I wouldn't go beyond those pieces. And I'd actually love to hear from some of you guys if you have a different opinion. So most of the times when people are looking to implement this thing called a CDP or a customer data platform, they're doing it for one of three reasons. They either want to improve customer satisfaction. They want to be able to personalize the customer experience. And I don't know in your organizations, if you hear the words customer journey mapping, personalization, those are really hot topics today. And I would think they're hot topics today because of Facebook, because of Google, because of Amazon. Because when you go buy something at Amazon, they're personalizing everything to you. So now every company that has a web presence wants to do the same thing. So if we take a look and say, what is a platform specifically? It is kind of like this spider, this hub that says, on one side, I've got all these things, sources of data that know something about my customer. It's my websites, it's my social media sites, it's mobile applications that I've deployed out to my customers. It's various data stores that I have within my organization. It's also IoT devices that I may have implanted in the physical boundaries of what I provide that all describe who this customer is. But on the other side of this, I need to be able to publish and personalize things to my customer. So how do I do that? It's that middle, that round piece that says, one, I need to be able to collect all this data in real time. Batch, and if it gets into real time and batch, then you have this concept of eventual consistency of making sure all this data is in the right time set, so to speak. Then I've got to, of this data, I've got to be able to identify, uniquely identify my customer. And that gets into some real heavy logic that some of these CDPs like Segment have been able to actually come up with a pretty sophisticated solution. And then the next thing is I need to be able to manage this data. So if you kind of reel back a few years, when I first got involved in back in the 90s when we would build data warehouses, there was kind of this concept of how do you master data? And you hear it today in words like data governance and master data management. So if you look at a CDP, it's encompassing what we used to do with data warehouses, which is ETL development to load data. Data modeling to be able to structure the data so that I can easily report on it. Master data management so that I can put some processes on top of my customer data to make sure that it's clean, it's accurate, and anytime somebody reports on it, they feel confident that they're getting the right answers. So the CDP is kind of packaging all this stuff up so that it has this API integration on the back end that says, now you can connect to this source of information. So real-time integration, master data management, customer identification, personalizing stuff, and API integration. When you hear CDPs, that's what it's really trying to do. When you hear AWS talk about, I'm going to build a data lake, they may not use those particular terms, but if you start looking at the components and the resources and the design patterns, they're kind of doing similar things. All right. If I go too fast, you guys kind of stop me. All right. So I thought now let's kind of, if you don't mind, I'm going to sit. Let's kind of frame the conversation from more of a case study. And this is a real case study. So we actually had a client, they're nationwide. They have apartment communities across most of the major urban areas in the United States. Boston, New York, San Francisco, San Diego, Dallas, those types of things. They don't have one in Atlanta, which I thought was interesting. They're going through this digital transformation. All of their web applications, very nice web presence on the internet. It's all this monolithic spaghetti API layers of Microsoft technology on premise. And it works, but its scalability is starting to become a real issue for them. Cost. They can't start to innovate on new ideas quick enough because there's so much, trying to think of the word, but there's just so much involved in just trying to make small changes. Probably a lot, your DevOps world, you
Right.
get into, you know, CI/CD processing on premise can be difficult.
Oh, yeah, it's very challenging.
Yep.
Yeah.
So they were asking the question, I want to personalize, I want to understand my customer's behavior. I want to capture the data. I want to be able to report on it, but I want to be able to personalize the messages. So think of it this way. They really have three concepts of a customer. We're only going to talk about two today. One is I'm a prospect. I'm living in Atlanta. I'm going to move to San Francisco. I don't want to buy a house. I'm going to rent an apartment. So I'm going to go to their website. I'm going to look at their inventory. And if I'm interested in something, I'm going to send them a note through their website and they're going to contact me. The other thing is, well, I have found a unit of interest in San Francisco. I've decided that I'm going to live on Nob Hill, which is right above Chinatown. Really love the spot. So I'm now going to submit my application. I'm going to be an applicant. Now I decided I'm going to rent this place. I'm going to be there, going to go into a 12-month lease. I'm moving to San Francisco. I'm going to live on Nob Hill. I now become a resident. So you've got this journey, this customer journey that's starting to pop up between, did you know me as a prospect? Did you know me as an applicant? Do you know me as a resident? And in this particular case study, they didn't know you as a prospect. They started to understand who you were as an applicant. Why? Because you had to give them a social security card, social security number. Then they knew you as a resident. If I left the Nob Hill community and went up to North Beach, they didn't know me in North Beach. So they had this problem that was a data problem and a technology problem. The fact that my identity to the company was only because of the lease that I held. So take all of that into consideration. Also take some other things into consideration. Their mobile applications and their web apps are not like going to Starbucks. I'm not going there every morning to get my coffee. I'm not going to Google every moment. They don't have, I'm not Park Mobile that is every time I leave the house, I need to get on that app and find a parking space. This is something you do on an occasion. So they might get about 2,000 to 3,000 prospect inquiries on a daily basis. So we're not talking about a high volume, high concurrency type of website. So once again, coming back to us and saying, we're going through a digital transformation. We're moving to AWS. We thought we should go with Segment. Should we do that? So that's kind of the lay of the land there. The other thing that they were starting to ask was some really interesting questions that really get into the design of any cloud platform. And that is, how do I deal with disposable infrastructure? Have you guys heard of these types of concepts? Okay. And think of your DevOps, you know,
Yeah.
disposable infrastructure. So in the AWS world, and I know, Michelle, I think the last month you were talking about Terraform, you know, you're building scripts that allows you to deploy resources into the cloud as opposed to going into a UI and pointing and clicking, so that if I need to tear something down, I can get rid of it and rebuild it. So that,
I'm
yeah.
sorry, to just promote AWS Atlanta for a quick second.
Yeah,
One of our first meetups when we started back up again was all about immutable infrastructure, where all of his servers, he destroyed every 2 weeks and rebuilt them. And it was very interesting. So if that's something that might be interesting, go back and check out.
Infrastructure as code, basically.
Yeah,
it's exactly what it is. And that becomes difficult on premise. That becomes extremely difficult. The other aspect is about what's called this bounded isolated components. Now, I can remember back in my Microsoft days, we had this concept of distributed communications. And so you got into a little bit of this distributed type of systems. But in the cloud world, you start to get into architecting these solutions that I have this one function, this component that does something, and it talks to another thing, but it's decoupled. If one thing goes down, it doesn't break anything else. So that's an important aspect of this. The disposable architecture, once again, kind of like this disposable infrastructure. If I don't need it anymore, I can easily get rid of it. And then the third thing is being to bring into these value-added cloud services. And I see this a lot with AWS. I look at it in its machine learning capabilities. If you think about the journey, the steps for machine learning in AWS, it is build your own, EMR, Lambdas, Glue, whatever the case may be. Use a managed service that in its management is taking care of the scaling and the performance of a model, SageMaker, or vertical applications that already have predefined algorithms for a particular use case. Forecast for doing time series, and what's the other one? I'm having a brain lump. Personal, like that for customer personalization. So there's these value-added cloud services kind of come in. So this cloud native design guidelines are very important. What they kind of landed on is we need to have a hub. This hub needs to mimic kind of this CDP platform. And three key things need to stand out. How do I have a unified customer model? Master data management. How do I have customer identification? Machine learning to be able to do some of this stuff. And then how do I have real-time data collection? Kinesis, Streams, and all of these other types of things. So enough with the solution stuff, enough with the case study. Let's kind of talk about the design pattern here. And like I said, this is not the only way to build something. There are many ways to build things in AWS. I've often looked at it like it's a cafeteria and you kind of go through the line, you pick out the resources that you want. And I think what's the beauty, if you go back to those design concepts, I can prototype something in AWS pretty quickly. If it doesn't work, I can snap on some other things and try to do some of this. So when we were kind of thinking through how do we build this platform, we knew ultimately that where they wanted to get to was a true cloud-based AWS native data lake. So now we kind of get into this conversation. What is a data lake? What is a data warehouse? So, and you hear vendors like Snowflake say, we are a cloud-based data warehouse that can also be a data lake. So those terms start to get interchangeable sometimes. A data lake is kind of this thing where I can store information, whether it's structured or unstructured. I can catalog it and people can get access to it. I can put some cleansing and some validation on top of it, but I don't have to go through all the rigid work of trying to build these very expansive data models to fit this stuff into it. Back in the 90s, when we built data warehouses, 50% of all data warehouse projects failed. And that was the good rate. And the reason why they failed is because you had to go out and figure out the data requirements. And then you would go out and do the data modeling. And then you would start to get into doing the ETL development of loading all the data. And then the users would finally get access to the data through reporting and they'd look at it and they'd go, this is not what we expected. Or there had been a change. And these types of projects could take 3 years to run. So the data, it's already too late, this is kind of pre-agile too. But this is where the data lakes have had a lot of success in the fact that if we dump the data, catalog it, inventory it, make sure that it's somewhat clean but still represents the source, then we can provide access to it in a much faster manner. It also creates a problem because it becomes a swamp as opposed to a lake, and that becomes an issue. But we kind of put together this this conceptual architecture that the platform itself is a series of layers. When we think of a data lake, most data lakes are kind of constructed that they have what they call these zones. There's a raw zone, as we can kind of see up here in the orange. The raw zone is, if I'm going to pull data into this platform, am I going to pull it and just make it consumable for the user right then? Probably. But I need to pull it in, and there's some data engineering aspects that says, how do I land it and have some quick validation before I do anything else with it? So if I'm going to go through this process of landing it temporarily, non-persistent, then I need to set up this, whether it's physically separated or logically separated this way, to say, I've got a raw zone that's really a landing pad. So all of this data starts flowing in, and in the case of AWS, it's structured to land in S3, which is cheap storage, and I can land anything there. Then you get into this refined zone that basically says, in the case of a CDP, now that all this customer information is landing, I need to stitch it together. I need to stitch it together into this customer journey that we were just talking about. And I need to run some pretty in-depth analytical models on it to do the identification. Because if we're talking about, in the case of this case study, I'm a prospect. The only thing that I've given to you in a request to identify me is my name, an email, and or a phone number. And just using heuristic business rules, you can't really identify somebody accurately in that manner. So the CDPs have a way of baking in an algorithm that basically says, I can take your cookies from your web browsing activities. I can take your demographic information that you've provided to me. I can keep history of that. And as I start to see you time and time again, whether your cookies, your devices, your IP addresses, and all these other things, I start to know who you are. I learn your identity over time. I don't know you immediately. So this refined zone provides that capability of capturing that type of information. And then your production zone basically becomes, how do I consume this information? All these other layers get into, how do I either govern the information, which are the green bars, whether it's identity resolution for customer identification, metadata management, how do I track all this information that's kind of coming in, or master data management, how do I put the right processes on top of the customer that if I see something that's wrong, how do I correct it? And then those purple bars, how do I configure that I can deploy things, and then how do I have this continuous integration? Your DevOps world really starts to play. On top of that, your red bars and your black bars are all about the compute services and the capabilities to run some complex modeling. So this is kind of the conceptual layout of the beginning of this case study of where they wanted to go futuristically. So now we have to figure out how to build into that. And so that's where we kind of get into really a lot of tonight's conversation. And I apologize if it's taken long to get up to this point, but this is kind of a very slimmed down design pattern that incorporates some of the data lake concepts, but really focuses more on how do I have a customer data platform. So you see we have raw, refined, and production. On our raw zone, we're using technologies such as Kinesis. And then we've got consumers and Lambda functions, very lightweight. For those that may not be familiar with Kinesis Streams, it's a very effective way of creating streams where data can be just loaded into the stream and received.
Okay.
Lambda does a really good job in this type of situation of, as a consumer, understand how to take action on some of those things. Streams need producers. They're often outside of the customer data platform because that is the process that is sending. I have seen situations where the producer is something that's been developed by the application development teams that are feeding data into it. I've also seen situations where other AWS resources like DMS, Database Migration Services, was used as a producer into the stream itself. The latter can be a little problematic. But in this case, the Lambda functions as consumers, whether it's real time or batch from things like Snowflake, they get landed into an S3 bucket. And when they get landed into an S3 bucket, they get kind of structured based on the way the data is coming in. What's the source? Is the information that's coming in, is it new records, updated records, deleted records? So you're kind of building a catalog of those particular pieces. And how long it stays in those buckets is dependent upon how long you want to keep this information around for triage. Normally, when we're designing things, it's 7 to 10 days to keep it around. Now, in this particular design pattern, what happens is when data lands in the S3 bucket, S3 has a trigger event that can be instantiated. So every time, and you've got like 2 different or 3 different types, it's I created an object, I updated an object, I deleted an object, or all of the above. So anytime those events occur inside of S3, it sends a trigger. And in this case, it can send a trigger to what we call step functions. Now, are you guys, and I don't know about the people, are you guys familiar with step functions? Okay.
I mean,
The
yeah,
concepts of it, yeah.
they're pretty much lambdas, but there's a difference between lambdas and step functions. I
Yeah,
don't remember.
so, so the lambdas are microservices. They're really just, it's a set of code sitting up in the cloud that is just waiting to be called. And the beauty of a Lambda function is that you don't pay for the execution of you don't pay for a Lambda until it's executed. Really quite inexpensive when it does. But the Lambda function in best design needs to do one thing. And if you think about if you're writing code, you're writing an application and you build a function inside of a Python program, good practice says, I'm going to build a function that does just one thing. It's the same thing with the Lambda function.
And it has a time limit and everything.
It has a time limit.
Yeah.
They've since upped it to 15 minutes, which is fine, but there's ways of getting around that time limit. Like we've developed solutions that we had to load data into Dynamo. Loading data into DynamoDB can be very cumbersome and time consuming, but you can parallelize the Lambda function. So I can run 1,000 Lambda functions at one time, all of them doing the same thing, which is really kind of similar if you think about EMR in AWS and the way that it works with Spark and those types of things. But the step functions is an orchestration. It's not a set of code that's running. It's what's called YAML files or JSON files. It is instructions for how you should call something, whether it's a Lambda function, another step function, or any other AWS resource that's compatible with step functions. So it orchestrates. You literally you are making a tree, and you can also develop it with error handling inside of it too. So it becomes a really nice additive if I've got multiple microservices that I want to connect together. And yes.
I was gonna ask, I've never seen a Lambda function before. Is that more of like a decorator where you just pull it in through a call some sort in code and then it would just only execute if you correctly called it and that's it?
Yeah, it's something like a decorator, and I can show you stuff, but it is like I use Python quite a bit in my Lambda functions or Node.js. It is a Python script. It's a Python
script.
Yeah.
Okay.
It's an application. It's when they talk about serverless applications, they're usually talking about lambdas. Like I build a lot of serverless stuff that just uses Lambda.
Okay.
So you don't have to worry about managing the infrastructure of your application. So it's just your code and it just runs that code every time it's invoked. You can schedule it as a cron from CloudWatch or something, or you can have a step function. I didn't know about the step function that you can do that with step function. So that's cool.
Yeah, and actually, so the step functions work really well. Not so much if you're building web-based applications, because there's a bit of latency in being able to read that YAML file and do the next thing. that's where things like Elastic Beanstalk kind of come in play. And now Kubernetes and containerizing that whole web type of stuff, which is not my area of specialty. Yes, sir.
We did have one question out there.
Yeah.
Step functions contain sequence of steps.
Yes, yes. I'm sorry. And you know what? I'll go in here in just a moment and we'll show some of this stuff too. And there is another thing that has been recently deployed in AWS called Airflow. So Airflow is a really interesting Apache project that has matured. As I recall, I believe it came out of Airbnb as they created this solution to orchestrate multiple Python programs together. And so now a lot of people are starting to do, and Airflow really took off in the machine learning crowd because it does a really nice job of integrating with Python, which is a really good language for machine learning. Step functions is equivalent to those pieces. All right, so what happens in this refined zone, we've got this step functionality that's basically encapsulating these Lambda functions that are doing its ETL processing. And as it's processing data, it's writing it to an S3 bucket. So I always know, what did I process? That gets washed out much quicker than the landing zone type of stuff. Now, once it's inside of the refined zone, there is a Lambda function that is actually used to import the data into DynamoDB. And at that point, you start importing the data based on the data structures that you want to report on. And that's where I wanted to kind of spend a little bit more time tonight. Once it's in Dynamo in this customer hub is that central focus point between data coming in and my queries into the customer profile information. That's kind of the heart of this platform. And then API services sitting on the top. Up above there, you see things like CloudWatch and SNS and secrets managers. You mentioned CloudWatch. That's your monitoring tool. You do have CloudTrails. You tend to have a higher cost when you start using CloudTrails because it's capturing a lot more information. Rules and events. You know, you putting a rule in an event CloudWatch, a great way to actually call a step function.
Step function
call
or
Lambda. Yep. And it uses the same format notations that cron jobs have. So
Yeah.
it becomes easy to understand.
It's very similar, a little bit different, but it's very similar.
Yep,
Yeah.
yep. And then SNS, which is the simple notification services, which is basically like from CloudWatch, I've got an alert, or from Lambda, or from the step functions, I want to notify somebody. I can now bolt in that SNS plugin, that component to do some of those things.
Or SES for email.
Or SES or email, yes. Now, I did run into some problems with SES and the fact that it does not validate an email address. So what happens is, if you've got this process where you're going through SNS and you're sending out emails to people and it's not validated, after so many times of sending out a bad email address, AWS will shut down your account.
Oh, I've never ran into that. The issue that I'm running into right now is not being able to send a secure email with the SES.
Yep.
So like that bang, secure bang, and then, you know, whatever in the subject to send an email, that's not like possible right now. I'm trying to figure this out actually.
Yep. So it's a good product. I see a lot of people put in SMTP inside of EC2 instances or a variety of other things to kind of get around some of these things. Secrets managers, quite often using secrets managers to basically store your credentials, especially like I had one program that was, it needed to go over to Snowflake every 5 minutes, pull data over. That's where you put the database connections and those types of things. Glue catalog. So all of this stuff that is falling into S3 buckets, you have glue crawlers that are scheduled. And it's constantly updating the metadata that we can store in the glue catalog. And along with Athena, I can query at any given point in the process what has landed in the raw zone, what is aired out in the refined zone. And now with this new connector that AWS has come out with to be able to connect Athena over to DynamoDB, I now have another SQL abstraction on type of Dynamo to write queries. And then CloudFormation. CloudFormation is just one of the many ways to do deployment of code. There's other ways. There's SAM which is another.
Serverless application model.
Yep. And then Terraform, which a lot of people use Terraform. So, all right. Let's, we've already kind of talked about some of this stuff. Let me just kind of mention this one quick thing and then we'll jump into some stuff here. So in the raw zone, one of the, and I was introduced to this just recently, but one of the issues that you may get into in the raw zone. So you've got this disparate data that's flowing in. It could be the streams, it could be batch. You've got a variety of stuff coming in. But when you get into the refined zone, you like to build some type of process that has some consistency on what it's expecting to see. Otherwise, you're having to code in to this functionality. Well, from Snowflake, I'm going to get data that looks like this in this format. In this Kinesis stream, I'm going to get to this. Well, there's vendors out there who have now come up with messaging specifications. And frankly, they've probably been around for a long time, especially in the web world. And I'm not a web world guy. But we used a company called Cloud Events. And it basically, it does a really nice job of embedding inside of Python. And it says, you take the data. So if we look at this structure over here, we can see that in this message, it has a header. And inside, beyond the header, I start to get into other objects that give me some information, such as the version number, which is not really that important. It's the version number of the schema for Cloud Events. But I get into the type and more importantly, the ID. Every message that I receive that comes through Cloud Events, I've got a unique number for it now. I can give it a source and a subject. So now those source and subjects now become the folder structure in my S3 bucket. And I don't have to build that out. I don't have to define it. It's dynamically built when I receive the message. And then the data down here is what I provide, what I'm trying to pass through this whole piece. All right.
So is that what those lambdas do in this?
So in this particular case, this lambda here, it says stream consumer. It is a very lightweight lambda. It is sitting there. It's using Boto 3, which is the library.
Yeah, SDK, yeah.
And you instantiate the Boto 3 object for being able to connect over Kinesis, and it's sitting there just waiting. It knows. And it's just waiting to listen for Kinesis to send out something that says, I got something for you. The Lambda just reads the stream, the producer that feeds it into the stream that's using Cloud Events that says, I'm going to send in this message into Cloud Events. And the consumer says, I know how to read Cloud Events. I know exactly what to expect. So the actual consumer for this, probably about 10 lines of code.
Yeah.
Very, very small, very lightweight because it's got to fire very quickly. The batch consumer, a little bit different. In this case, in this example, it was going against Snowflake and it was pulling down probably about maybe 1,000 records every 5 minutes. So the body of the data would be 1,000 records, 1,000 JSON records, but it would still have the header upon it. So I know exactly what I'm trying to get out. All right.
So this is what you're talking about, where it's semi-structured, it's got some outliers, it's got some faulty data, but it has a simple structure that can be used quickly with a little bit of execution.
Yep. And when we get into the kind of the semi-structured, the unstructured data is going to be, you know, I've got a whole text of stuff and I'm just throwing it out here and I want to be able to store it.
Got it.
As opposed to in a database, I've got a table. It's very rigid. All right. I need to be cognizant of time here. Let's, the other things that I've gotten, I'm happy to go through some of this stuff, but what I'd like for us to do is, let's talk about this particular piece. Current slide. All right. Just very briefly about this. So the production zone, as you recall, we talked about, we've got DynamoDB. We can talk about why we use DynamoDB as opposed to RDS and those other things. Primarily, Dynamo is a good source, relatively inexpensive for high volume quick transactions. You know, it is not a good solution for analytical processing. Because when you design a Dynamo table, the first step is that you have to kind of figure out what are all the possible use cases I'm going to have on this. When you design a database, a warehouse or a data mart or anything or set of tables, you're not worrying about every nuance of a query that's going to happen. You're more, in the case of this relational design, I know I'm going to have a table of customers, a table of leases, and probably a table of their browsing history. I don't really care how they're going to go query on browsing history. I might over time, because I'll have to put indexes on that to make it perform faster. But I also have these physical representations of data that have to be linked together. And the Dynamo world can take that same concept and create what we call a single table hierarchical design, where I have one table that contains all of this information. And because it's NoSQL, I'm not tied to a schema in the table other than the partition key and the sort key. So in the case of this example of customer profile data, I can have one record, one item in the Dynamo table that is the customer record. I can have other items that represent the lease records and other items in the table that represent the browsing history records. And so I can do one query against the Dynamo table and pull back the customer's complete profile, as opposed to constructing a query that has multiple joins. So let's look what that actually looks like here real quick. All right, so I'm in Dynamo here. This is my own personal thing. And so I had created this prototype to kind of show some stuff. I've got this table called customer profile. So if we look at customer profile, what you can see, let me see if I can make this a little bit better. You've got this concept of the customer key, that's what we're calling the partition key, and we've got the customer sort key. And we've created, and let's do a query here. Let's say that we're going to query with the partition key equals the customer key of 141. And we'll go back down. No, that's not what I want you to do. And let's search that. So now what happens is, I don't know if this can be seen that easily, but you can start to see in one query, I pull down all of this. So if I go and I look at my customer item, I can see I have the base customer information. I have name, gender, email, birthday, but I also have this customer key, which is a primary key, as in addition to the customer sort key. And you'll notice that the sort key is just called customer. It's a literal. You'll also notice that the sort key for lease is the literal of lease plus an identifier that now makes this unique. So I have embedded this table relationship inside of one table. And if I wanted to say, bring me back all of the leases, well, then in that case, I could say where it begins with
anything that starts with lease.
Lease. And so now you've kind of one table. Now you may say, but now I'm storing everything inside of the one table. But that's kind of the design of NoSQL. You don't really want to have these separate tables that you have to relate through code, because Dynamo will not relate that for you. So I found this to be a really great way of kind of doing this type of work. In this one particular client, for the real estate, we had each one of these sort keys was represented as a domain of the data. So we had a person domain, we had a lease domain, we had an application domain. So it all kind of lumped into one area, and I can easily add to the record with additional attributes because it's schemaless. Right? Okay. And then the other thing, if we were to look at it, because we've instantiated these APIs now, and so I've kind of created very easily and quickly an API gateway that says, I'm going to create an API service where its root domain is customers. And it has a resource of profile. I'm going to do a get. And if I wanted to test that out, I think I've already done this here. We'll done it again. All right. Let's just make sure that's working. Okay, it is. And as you can see, what it does is it pulls back. This is my item for a browsing history. And I can see in here what I've got is, you know, you see things like the IP address, the URL that they were browsing, the application name. This is all the stuff that comes out of your web logs, you know. One of the things that we did with this particular client is as they were sending in the request from the prospect that says, contact me, we were scraping off of that web session their cookie IDs. And we were storing the cookie IDs in the customer profile so that over time we could start to do identification not only on their first names and last names and other things, but also their browsing behavior. And so now with all this information and in real time on the back end of this stuff, there's an API integration that says, hey, David, I just saw you were looking on the hill. Have you thought about the one on the beach? So you've got real-time personalization. And that's what the customer data platform is really trying to get to. So, all right, let me kind of stop there because I kind of have a feeling I've gone around and around and around. What questions do you guys have? What thoughts do you have, either in the room or online? And you wanted to see a Lambda function.
I mean, yeah, if we have time.
Yeah, useful. So
So
go ahead, please.
we were just talking online about state and microservices and lambdas. So we were talking about step functions and how normally a lambda does not have state, but if you're going to put it into steps, then the lambda kind of knows which step it's in. So that kind of allows you to use the state of that you're in the step function, if you like.
Let me do something. Let me show you the Lambda function so you kind of get a feel for it. API does a great job of in this user interface. And I'll be honest, most of the time when I'm dealing with AWS, I'm doing it from CloudFormation. Okay. We can show how the API gateway is created in CloudFormation. But I like this user interface because it allows me to look at the API configurations, the resources, but then I can see the whole process of sending a request, integrating with the Lambda, and getting the response back. So we go over here and we click onto the Lambda function. And don't laugh at my code. This is really simple stuff. So very simple. Prototype code doesn't have any type of error, but it's to simply say, this one little function here is doing one thing, and that is, I am passing into, as a query string parameter in the URL and the request, the customer key, which was 141. That comes into the Lambda function. It has these things called events, context. The event is a JSON object that gets passed into the function. You can put anything you want into that event object. And then in this case, I knew to read it from this object called query string parameters dash customer key. That's being passed into it. So now all I have to do is take that value and pass it in to my DynamoDB query function that is instantiated from the Boto3 library. Very simple code to simply go everything I know about that.
Thank you.
Yep.
Online to show some of the code you're using in Zone.
Okay, that I don't have with me.
Okay.
That's where we start to get into we start to get into the model piece. So I apologize for that. Let's go look at this. And if I don't have a function that is already available here, let's see if I do. Yes, here we go. So this is what a step function looks like. So as we can see, it kind of visualizes and it says you have a starting point. These boxes present nodes or sections in the step function definition. They call it a state definition. It is as we see right here, it's a JSON script, but it can be JSON or it can be YAML. But it's just a file, a definition to explain what happens when I do execute query right here. Well, if I see right here, I've got states. And it says, I want to start, my first state that I'm going to start at is going to be on execute query. And I want this to be a task. I want to go do something. What's this task going to do? It's going to run this Lambda function. What happens when that Lambda function runs? Well, I want to capture any errors that may come up. And so this is one of the beauties that I kind of like about the step function is I can put an error handling strategy outside of the Lambda functions, inside of the step functions. And then it can now be kind of consistent. And then it says, all right, well, if that's successful, what do I do next? Well, my next thing is I want to do this validate query execution. Well, what do I do there? Once again, it's another task. I'm going to call another Lambda function, and I'm going to capture any errors that happens to work. And if I continue on, then I've got to, what happens if none of these operations here work? I've got to catch all. So this is really I think it's a great way, especially on the data processing side, to be able to stitch together microservices. Now, if you're talking about from a web perspective, probably not, because there's latency in every time that it's making this decision.
That's probably why I never had step functions.
Yeah.
But where does it send all this information? So let's say I get errors, where is that being logged?
It's being logged in CloudWatch.
Oh, okay.
Yeah.
So yeah, CloudWatch logs.
By default, everything is CloudWatch.
Yep.
And you can, so like what we have also done here, that there's a function called error handler. So if we go down to error handler, where is my error handler? Where is it? Where is it? There it is. I'm writing the message to another Lambda function, which gives me the ability to say, I'd like to do something else. I might want to stuff it in DynamoDB. I might want to save, I might want to capture the record associated to the error and put it into S3. So it's pretty easy to write, pretty quick to write some of this stuff. I've seen at one client, we built step functions that had at least 400 nodes in it. And what that process did, it was a beverage company that had formulas, and they needed to get the formula information in real time downstream to commercialize on this stuff. They had a process that ran 3 days if it was lucky. And so we turned it into 5 minutes. And we did this in AWS by using microservices written in Node.js, and then using the step functions to basically orchestrate all of these services. So we didn't have to worry about, did it have to be in 200 milliseconds? You know, as long as it was in seconds, we were good on that. So, all right. Any other questions? I know we're at 7:07, so the one thing that I really wanted to do tonight is let me bring this back up. So you guys are smart people. Evidently I'm not, because I can't get to the right thing here. How would you design this? How would you improve it? And looking at this design right now, where do you see any fallacies? where could there be a section in this design that might be problematic or to significantly increase the volume of transactions?
So Dennis, why'd you go with Dynamo?
That is a great question. And I'll give you two answers. One, Dynamo does a really good job. So the requirement from the client was, I need to be able to have an API that does identification in real time in less than 400 milliseconds. So Dynamo is a great resource for high volume transactions like that. It has, from my perspective, it has some challenges because getting data in and out from a batch standpoint can be very cumbersome. Like, we had to load millions and millions of records to see Dynamo. It took days to do some of that stuff. Now, we had a lot of learning too, in that particular case. But the other real reason is that the organization was already using Dynamo. And so anytime that I tend to work with clients and we're designing systems, the very first thing that I ask is, what do you currently use in your technology stack today? You mentioned doing C#, and I've seen a lot of people do .NET Core Lambda functions. Works really well. There is a bit of an overhead in .NET Core from my perspective, because there's the overhead of being able to process, pull it up and run it, as opposed to Node.js and Python actually works much faster. Node.js is probably a better for Lambdas because it has this asynchronous capability built inside of it. But I always try to look to say, what technology are you using? Because at the end of the day, they have to take ownership on this. And if they know Python, if they know DynamoDB and it's working well for them, sure, then it becomes just kind of your personal preference. Yeah. But in this particular case, this client is actually starting to rethink whether they want to do Dynamo, because they had set up a process that says, I'm going to replicate from SQL Server on-premise to a Dynamo table using DMS, which is the Database Migration Services. DMS is a great solution for migrating things. It becomes a little problematic when you start to use it, like in the SQL Server world. You've got this thing called transaction replication. It does a really good job of real-time replication of data. DMS can be a little problematic in those areas. It tends to lose sight of its change data capture and its pointers and those types of things. So, any thoughts on how you would change this?
So we really didn't talk about how are we. We didn't talk about security at all.
Yeah. No.
Yeah.
So in the security of this piece, this particular. So this client, what I see in most places in this case study is they have kind of a federated AWS strategy. So I'm going to have multiple accounts. We actually started to build this platform where there was an account for the R&D group, where all the applications live. There was an account for the data science. There's going to be an account for the. And that actually became problematic because of their security rules. Mm-hmm. And it became problematic because of Kinesis. Kinesis needs to live in the same account as the consumer. The consumer can't live in another account. Or at least if somebody knows how to do that, I'd love to listen to you. But then we finally went back and all of this. Applications live where you want the hub to live, be in the same account. Your data scientist can go have their own account and do whatever they want to do. So because of that, the API services and all of that, we didn't have to implement security keys because it was all behind the firewall anyway.
Okay.
Yep.
And you mentioned using the Kinesis Stream.
Mm-hmm.
I know there's another.
There's Kinesis Firehose and there's Kinesis Streams. Kinesis Firehose kind of gives you a little bit more flexibility in writing directly to S3. Okay. I think both of them work really well. There's also Kafka.
Oh yeah, Kafka, yeah.
And Kafka is a really good tool. So that's the thing about AWS to me is that they're adding new functionality like every quarter.
Mhm.
You know, I like to let things kind of simmer a little bit and then take it on. So like Glue, they just recently implemented, I say recently, maybe within the past year or so, the ability to use Spark, streaming Spark jobs, which they didn't have before. So Glue, when we think of Glue and we think of the ETL thing of Glue, it's traditionally been a batch process. But now because of streaming Spark, it can be real time. And that gives you a lot of power. So, but the one thing that I've always wondered about, and I don't know if you guys can see my cursor, but we've got this dependency here between the raw zone and the refined zone of an S3 trigger. You know, what would happen exponentially increase the amount of transactions coming in? Is that something that, does that become another stream where I can shard and I can scale? Will the trigger in S3 still perform if I do twofold, 100-fold of the amount of transactions?
Could you use SQS?
Yes, that would actually be a really good way of doing that, to actually build the queues. And now that you mention that, we actually had a colleague at our company, they had a problem with DynamoDB where they had to load millions of records. They wanted to do all Lambda functions, so they had to parallelize. In order to be able to capture at what point a Lambda function needed to pick up the next set of data in this parallelization, they used SQS to kind of create this queuing system. And so that was, we should get him in here to show that. I thought that was really remarkable. I haven't heard anybody ask, why did you build data integration in Lambdas as opposed to using something like Glue where you have Spark available to you? Any thoughts?
Scalability.
Huh?
Scalability.
Ability, yeah. Well, are you thinking that the Lambdas would have more scalability than the Glue jobs?
Yeah.
I was gonna ask if it was cost.
Yeah,
Um,
because I think you have to run like invoke Lambda like 1,000,000 times before you get charged or something like
Yeah.
that, right?
Lambda is much cheaper. Glue does a really good job if it's massive. I mean, if you're loading lots of data, Glue will run very fast. The thing about Glue is, somebody asked me the other day, should I build a Glue job or should I spin up EMR to do ETL? And I'm like, well, Glue is EMR. When a Glue job runs, the very first thing it does is it spins up an EMR cluster. Gets the data that it's processing, loads it into the cluster, does whatever transformations and apply that you've written, and writes that out to where it's going to go and then spins down the Glue cluster. That's why from a batch process, it tends to be, from a real-time process prior to the Spark streaming, it wasn't really feasible. But now with Spark streaming, they're using the pure Spark architecture. So anything else? Would somebody have done something different than Dynamo?
So you picked Dynamo for what? For the speed?
Speed, and it was being used at the client. It was a known entity.
Yeah.
What, do you not think you could have handled it in a more of a
RDS?
structured?
Yes, my
It could have.
Okay.
It could have. This is where you kind of get into personal preferences, because the stakeholder was like, he really did not like databases. He goes, it's just going to be way too slow. So a lot of the stuff is based on perception, opinions. That's why I think that there is no one way to do anything in here. There's all kinds of ways to do a lot of stuff. It's just whatever you feel most comfortable with. So, any questions or anything else you guys would like to talk about?
Outside of providing real-time data via the API, are they doing any reporting? off the data for internal use, executives, things like that? Or is it going off the DynamoDB or?
So no, reporting not on Dynamo, but that's a great question because, and this kind of goes back to the purpose of the hub in the customer data platform. It is creating a set of master data that can be used by other systems. So the immediate need was in real time. And this was kind of the real immediate need. I've got a user browsing my site, looking at an apartment in Nob Hill. They sent me a request online that says, I'd like to schedule a tour. How do I identify this? That was the primary use case. And so that person gives you first name, last name, email, phone. So through an API service, we make a call to Dynamo. We run through some matching logic. And then we return back. This is who we think the person is. Are they new or have we seen this person before? And to do that within 400 milliseconds. So, but in order to, it doesn't mean that you're running a machine learning model in 400 milliseconds. It means that on the back end, going into Dynamo, you're running that model and building out that stuff so that on the front end, it's more business stuff. Yeah. But that was the real driver. Now what happens is now you've got a repository, a profile of customer that is replicated on a more frequent basis down into their analytical engine, which was Snowflake at that time. And now what they've got is known entities of customers with a unique identifier propagated back into. What other questions? Anybody on the phone?
Can I ask whether Elasticsearch would have been useful instead of DynamoDB? How would you compare those two?
My experience with Elastic of in memory and would have been a really nice thing to be able to put stuff in memory for quick access. Because of the volume, we were with about 10 million records of customers. That's just a customer record. Now extrapolate that to all of the uses, cookies, browsing history. It starts to get well into the multi-millions of records. And so that might have been a bit of a challenge. But we have done things where in more of a streaming capability, I've got a piece of data that's coming in. I might need that. Great example. I have a user who is browsing my site. They have clicked the button to submit a request to come visit an apartment. I capture that information. They click it again. They click it again. They keep clicking, thinking something's broken. Do I want to constantly make that API call every time? Or do I want to cache that original hit and tell them, you've already clicked once, don't do it again? That's where I see kind of that caching ability coming into play. But I'd love to hear from somebody else who's used it. Anything else?
Anything else? What is in one region?
Oh, that's a great question. Yes, it is all in one region. That's a really good question.
Yeah, because if you use just a bunch of Lambda functions, then it probably won't cost much to put it in another region, like multi.
Yeah. So the reason why that's a good question is I had a situation, Snowflake, for example. So Snowflake is a SaaS cloud-based data warehouse, data lake. When you deploy it, you have the option that says, what do I want to deploy this on? AWS or Azure or Google? And then they'll say, well, I'm going to deploy it. On this particular client, they're a big Snowflake. They wanted to deploy in the East region, but Snowflake in the West region. even though it was a separate account. The ingress fees, loading data in and out, going between those two regions was going to be astronomical. So they actually had to go back to Snowflake and tell them, we want to reinstall our instance into the East region so that we no longer have these ingress fees going between the two regions. I've also seen some customers that would pick a region that was more geographically located to where their on-premise data centers were. Once again, to cut down on the egress fees. So that's a great question. And the other thing you'll find is certain AWS resources are only available
In North Virginia,
Yeah. So there are some, like if you look at some of the design patterns and prototypes that they have on the site, it may only be in like the West region or something like that.
You mean you'll notice it on like the GUI or the hub whenever you go on data?
Yeah,
Oh, yeah.
yeah, it's
Oh, wow.
when you go, and this is something that captures, you see right up here, it says North Virginia. Here's all the different regions. Now, S3 generally is kind of regionless to a certain degree. And there are some resources that are regionless to a certain degree.
Global, yeah.
Yeah, but like I've gone into certain environments and I'll look around and go, there's nothing in this region. And I'm going, yeah,
The one in Singapore. for
change
sure.
the region. So, yeah, that's a great question. I like that.
So I'm curious what's in your rock history, Dave.
So I was playing around and I love music and I found on Kaggle, and it was a data set of all the major rock songs since the beginning. And so I was building a prototype to be able to demonstrate something. That's what it was.
That's cool.
So, yeah. Normally I use cartoon characters, but you know.
Kaggle has some great data sets.
Huh? It
Kaggle
does.
has- Yeah, fantastic. The Titanic one's the classic one everyone knows about.
Now, and let me give a plug for Makaru. Have you guys ever heard of that? Makaru, okay. So all of this data here, there's probably somewhere about maybe 2 million records. Well, how many is it? 1.3 million records. No, I'm sorry, 6,000 records. Never mind. But that's people's names and addresses and stuff like that. They're not real. So I was able to use this tool called Makaru. And you give it parameters and schema and definitions, and it will build a fake data set for you.
Oh, that's cool.
Yeah, that was really nice. I know, so. Anything else? All right.
Once, twice.
Well, thank you for your time.
Yeah, definitely. Thank you guys. Thank everybody, guys and gals, for joining us tonight. It was good to see some of you guys in person, and hopefully we'll get to do it again next month. There we go. Like I said before, next one's on the CDK, so that should be pretty good. But again, we'll be in person, Lord willing, and thanks, guys.
Thank you. It's been really good, really useful.
Michelle.
Yeah, thank you for hosting.
Absolutely.
Well, no, thank you.
That was awesome stuff. Thanks.
It felt a little scatterbrained to me, but I hope you got something good.